Hello, you're welcome. All right, so now we are going to be looking at pressure. Okay, so what is pressure? In physics, we define pressure as the force per unit area acting on an object. Okay, or the force acting per unit area on an object. So that means invariably pressure, which are represented by the letter P, is actually force, right? Force, then per unit area. So now the SI unit of pressure is gonna be Newton per meter square. Okay. So now from what we have here, we can simply say that pressure is actually inversely proportional to area. So what does that mean? It simply means that the smaller the area, the more the pressure. All right. Okay, and that is an experience you get when you actually exert pressure on your skin. Okay, probably using a very large object. You compare it to when you exert that same pressure on your skin using a needle. Okay. You discover that needle having a small surface area, okay, will definitely make more impact than a large object. So the smaller the area of the object, the more pressure, okay, it actually produces. So please take note of that. All right, so now we are going to be looking at liquid pressure. Okay, the pressure in a liquid or even fluid. Okay, fluid pressure. Let me the characteristics of liquid pressure is same as fluid. Is a combination of is either a fluid is either a matter in its liquid state, okay, or gaseous state. So anytime you hear of fluid, we are referring to either liquid or a gas. Okay, so now we are looking at the characteristics of pressure. Okay, liquid pressure, the characteristics of liquid pressure. Now one characteristic of liquid pressure, of course, when you have a container that contains liquid, for example water, all right, now the water molecules will definitely exert pressure, all right, on the container. So inside the container, actually inside the the container, okay, where you find the water, there's pressure acting inside, and that is why for those of you that study biology, we are told that one of the abiotic factors that affect aquatic organism, that is organism that lives in water, is pressure, the water pressure. Okay, because the it is much easier to walk on earth, to walk on air, right? Because of course, what the only fluid you find uh, uh, on earth is actually is air, right? So it's easier to walk through air than to walk through water. Why? Because air does not have as much pressure as compared to water. All right. So that means the pressure in water is of a very is of a significant, okay, point of study. Why? Because organism that lives inside water, okay, actually are being affected by the pressure of water. All right, and that is why you see fishes, the bodies of fishes are actually streamlined in order to provide okay, uh, a very the surface area, okay, or a less surface area that will enable them navigate through the water, okay, without being affected by the water pressure. Okay, so now we are talking about the characteristics of pressure, okay, in liquid, right? So now one characteristics of pressure in liquid, number one, is that the pressure in liquid, okay, actually varies with depth, varies directly with depth, or is proportional to depth. So which simply means that, what does that mean? That simply means that the lower you go, the more pressure you actually encounter. Okay, so the pressure at lower than the liquid is actually greater than the pressure higher than the liquid. All right, now how do I actually to explain that? This is one explanation of that, or an experiment that actually illustrates that. Let's say this particular container is filled with water, all right, then another borehole at different levels of the liquid. Of course, you know that water will actually issue out, right? with different pressure. The one up here, okay, issues out, probably go to this length. The one up here will actually issue out with a greater pressure because it is of a lower depth. The one up here issues out with also a greater pressure than what this one down here push with the highest pressure. Okay, so that means pressure actually is proportional to depth. All right, I hope that is well understood. Number 2, okay, pressure at any level in the liquid, okay, act equally in all direction. Pressure at any level in the liquid act equally in all direction. That is simply put this way. Let's say at a particular level, okay, in the liquid, the pressure, okay, acting upward, all right, should be equal to the pressure acting downward. The pressure acting leftward should be equal to the pressure acting rightward. Okay, let's say the pressure acting downward is P1 and the one acting downward is P2. So P1 is equal to P2. So it's actually the pressure act equally in all direction. All right. Number 3, the pressure is always perpendicular, okay, to the surface of the liquid. Well, is that? Oh, please pardon me. That is not applicable here. But the pressure, this is very important. Okay, characteristics. Pressure, we already say, is actually proportional to depth. Then, of course, pressure also is dependent on the density. Okay, the pressure is dependent on density. Invariably, the pressure is proportional to density. Okay, the more denser the liquid is, the more pressure it actually produces. The more the density of the liquid, the more pressure it produces. So if you are being asked between water and mercury, okay, which one will produce more pressure? Of course, is going to be mercury, because mercury is actually denser than water. Okay, all right, so now I'm going to let's actually create a relationship of pressure. I'm going to give you a formula of pressure. Here we already have that pressure is equal to force all over area. I'm going to give another formula of pressure that is related, okay, with the depth of the water or depth of the liquid, right? So from here, I'm going to derive the formula. We already said that pressure is equal to force all over area. Okay, so now in physics, we know very well that force, which of course is something as a weight, okay, which is mg, and we also know that volume, okay, or better still, density in physics, this is the symbol of density. We use symbol of density. Density in physics is given as mass all over volume. All right, so invariably now, if I want to make volume the subject of formula, I will simply say that volume is equal to mass divided by density. Okay, mass divided by density. All right, so where are we going with this? Okay, I'll tell you where we are going with this. So with what I have now, I want to replace all this into this formula. Force is mg already. Okay, and another thing you should also know that we've actually treated this on okay, in we treated this is in mathematics or measurement. Okay, measurement and unit. All right, volume of any container is always given as the base area of that container, okay, then multiply by the height. So invariably now, since we already know that volume is mass all over density, okay, so I can simply say that volume, okay, since volume is mass all over density, all right, so invariably now, from what we have here, area, from this formula, area is going to be equal to volume all over the height, okay, and the volume here is mass all over density, okay. Then of course, please pardon me, volume is mass all over density. Mass all over density, right? Then don't forget that this volume, then volume is the area is also divided by height, okay, times height. Okay, so now that's exactly what I'm going to substitute into this particular expression. So in this expression, I'm going to have pressure being force all over area. Force is mg, okay? Then divided by area, and the area that we have here is mass. Then divided by density multiply all over h, okay? Mass divided by density h, okay? So mass cancels mass. So I'm actually left with all right, so let me just okay, let me put that aside. All right, so here we go. So mass cancel mass. So I'm now left with pressure being equal to I have to rearrange this equation. Pressure is now going to be equal to G, of course, 1 all over reciprocal of density height. So if I should actually know what reciprocal is, that simply means that I have to invert this, okay? Then density H will actually is going to come up. So we now have that pressure, okay, is giving us density multiplied by H, then multiplied by G, okay? So this is just a proof of a formula. You can actually probably go through it again to see how I actually proved it. But most importantly, it is just this formula I want you to take note of. That pressure is also giving us the density of a fluid or liquid, okay, multiplied by the height of the fluid, then multiplied by acceleration to gravity. So the pressure of a fluid, apart from giving us force all over area, is giving us density of the fluid multiplied by height of the fluid or the depth of the fluid, okay, then multiplied by acceleration due to gravity, okay? So don't forget this, that this is density, while the h here either represent height if you are dealing with altitude, that is in air, or it represents depth, okay, if you are dealing with liquid. All right, so please take note of that. Okay, so I think we can solve some question. All right, I'm gonna do justice to some questions. So I have this question here, I have to maximize it. Okay, so this one goes like this: the hydrostatic blood pressure difference between the head and feet of a boy standing straight is 1.65 times 10 raised to power 4. So write the parameter 1.65 times 10 raised to power of 4. Okay, of course, that should be Newton per meter square. That's the pressure, okay? Let's proceed. Now, find the height of the boy. The height of the boy, question mark. Then what was given? Okay, given that the density of blood is 1.1 times 10 raised to power 3. So the density of blood is 1.1 times 10 raised to power 3. Okay, kg per meter square. And of course, you know G, we'll still use G, that's 10 meter per second square. So in this case, now you know the formula that goes. The pressure is going to be equal to density multiplied by G, then multiplied by H. Pressure is 1.65, then times 10 raised to the power of 4, equal to density, which of course is 1.1 times 10 raised to the power of 4, multiplied by acceleration due to gravity, then multiplied by height. Okay, so the height of the body, that's what you're looking for. So from what we have here now, the height of the ball is going to be equal to 1.65 times 10 raised to the power of 4. Okay, then divided by 1.1 times 10 raised to the power of 4. Times 10 times 10 times 10. Okay, so now we are going to simplify this what we have here. Okay, so what we have here now, we are going to simplify it. So with our calculator we have 1.65, okay, divided by 1.1, that's 1.5. 10 raised power 4 cancel 10 raised power 4, then this divided by 0.1, that's 0.15, okay, and that is going to be 0.15 meter. 0.15 meter. All right, so I hope that is well understood. Okay, so we will proceed. Okay, let's check some question again. Let's look at another question. Okay, so this one goes like this: a reservoir 500 meter deep is filled with fluid of density 850 kilogram. Okay, let me clean up. A reservoir of density, okay, reservoir 500 meter deep, that is the depth, which of course is height, 500 meter. The density of the fluid is 850. kg per meters cube. All right, then if the atmospheric pressure P is 1.05 times 10 raised to the power 5, 1.05 times 10 raised to the power 5, the pressure at the bottom of the reservoir is, okay. So now in this case, now we still apply the formula. Solution: pressure is given as density multiplied by G multiplied by H. All right, so density is 850 multiplied by G, which of course is 10. Okay. Okay, atmospheric pressure. What I have here is the pressure here is the atmospheric pressure, ATP. So the atmospheric pressure, okay, ATP. That means that particular liquid was actually exposed to the atmosphere. So two pressure acting on it: the atmospheric pressure that's acting from the atmosphere plus the pressure of the liquid. Okay. So invariably now, let's get that over with. So what do we have? Density multiplied by G, then multiplied by height. That's 500. Then don't forget that the pressure, okay, is going to be pressure that is due to the height of the liquid, and of course I have to also add with the atmospheric pressure. We'll talk about we are going to discuss atmospheric pressure just now, okay? So but let me just put that. So everything I have to actually add atmospheric pressure to it. 10 raised to the power of 5. So I'm having 850 times 10 times 500. 850 times 10 times 500. So that's gonna be 42500. 4250000. Okay. Then plus 1.05 times 10 raised to the power of 5. All right. So if I should put this in a standard form, it would be 1, 2, 3, 4, 5. Okay. So that should also, this is going to be 42.5 times 10 raised to the power of 5. Okay. If I'm not mistaken. All right. Then of course, plus 1.05 times 10 raised to the power of 5. Okay, so now let's do this. So what is common? 10 raised to the power of 5 is actually common, so I take it out. Then I have to add 42.5, then plus 1.05. So what do we have after adding that? We have 42.5 plus 1.05. That's 43.5. So I'm going to have 43.55 times 10 raised to the power of 5. 43.55 times 10 raised to the power of 5. Okay, so that will be my answer. All right, so we will talk about atmospheric pressure in the next video. See you in the next video. Thank you.